welcome back to AGT STEM. Today we're going to be watching a video about gold. So, without further ado, let's hop to it.
Okay, so what we're going to do today is something quite different. I've never done it before. We're going to take Brady's cheap Casio watch. It looks like this. We're going to try and make it gold, my favourite element. So what we have here is a contraption that Neil made for evaporating metals. So what we have is we have a chamber, vacuum chamber, and then we have in here 2 electrodes, and then the gold's going to get really hot.
Gold is an element that has really excited people for thousands of years. And one of the reasons is that it's one of the very few metals that you can find in nature as the metal. In the countryside, in the right place, you can find lumps of gold. And once or twice in human history, people have found really large lumps of gold, weighing a kilo or more.
The gold's going to melt at a very high temperature. Eventually the gold atoms are going to start to come off the gold. Hopefully we're going to get a nice gold coating on the watch. It's going to look like a expensive watch.
Gold is a very unreactive element. It doesn't react easily with oxygen or most of the other elements, and therefore it can exist in the environment under conditions where most other metals would combine with oxygen or some other element to form minerals.
So what we're going to do here is we're going to test the whether or not the watch can withstand the vacuum. So we're going to put it into this chamber before we put it into the vacuum chamber over here, because that one has a turbo pump on it. If the watch does explode, it might ruin the turbo. So we're going to risk this one first.
Gold is quite a large atom because it's down near the bottom of the periodic table. And so it doesn't form very strong bonds. And it is forming strong bonds that makes chemicals or makes elements reactive.
So we're applying the vacuum now to the watch. It all seems okay at the minute. Doesn't seem to have exploded. Still working. Is withstanding a pressure of 0.1 millibar.
Metals look like metals. That is, they have the characteristic shininess, because of the electrons in the solid are so-called delocalized. That is, the electrons aren't attached to one atom, but are essentially shared by lots and lots of atoms. And in order to get this effect, you only need a very, very thin layer, a few atoms thick, 10, 20 atoms thick, and it already looks shiny and you can hardly see through it.
So what I have here is a little piece of gold that we're going to put into the boat in the vacuum chamber, and we're going to heat it up to over 1,000 degrees, try and get it to melt, to evaporate. You don't need an awful lot of gold to actually get a gold covering on the gold coloured covering on your watch. So actually it's going to be very thin covering of gold, nanometer level thickness.
Gold, like other elements in chemistry, goes through fashions. The famous chemist Michael Faraday in the 19th century discovered that you could form very small particles of gold in water to make a solution which was called a colloid, where these tiny lumps are so small that they don't settle out. So even after years, the liquid is still coloured. And in the last few years, the last 10, 15 years, people have suddenly discovered that gold can be used as a catalyst for quite a few different reactions. Some of them quite simple, like carbon monoxide, CO, reacting with oxygen to make CO2, which is a reaction that's sometimes quite difficult to catalyse, and gold catalyses it very well.
So I'll put my little bit of gold into the onto the boat there. Retake. So I'll put my little bit of gold onto the boat here in the middle. So this is a really high vacuum now. I think we're almost ready to crank up the current between these 2 electrodes. Going to heat up that bolt in there where the gold is sitting on, and we're going to evaporate the metal onto the watch. Temperature's going up and up now. We're slowly turning it up. So the gold is heating up. Can't see it melting quite yet. We might need a little bit more heat.
It's very difficult to find out how much precious metal is mined because the people who do the mining keep very quiet about exactly how much they get out. Some of the elements, like rhodium, are mined on a very small scale, perhaps 20 tons a year of metal, even though millions of tons of rock come out. Platinum and palladium are at least 10 times more than that, 200, 400 tons a year. And gold is about another 10 times or so, I think. And in a platinum mine, gold almost comes out as an impurity. They mine the gold even though they're looking for the platinum, but they get obviously quite a lot of profit from the gold.
Okay, so the gold is melting. I can see it melting here in the boat. The gold is completely liquid now. So what's happening now is the gold is boiling away on the hot surface. The atoms are coming up here, depositing on the walls of the chamber, and the watch is in the way here. So all of these gold atoms that evaporate from the boat hit the watch and hopefully deposit here, give us a nice thin gold film on the outside of the watch.
I've had very little gold. I don't have a wedding ring, although as you've seen from our videos, I am married, because gold can react with mercury and it goes silver then and it spoils the rings, though you can polish it off. So I've never worn a ring and I don't have any gold jewellery at all.
So you probably can't see it very well on the screen, but what's happening here is I can see the gold in the boat is boiling away vigorously. We're getting evaporation here. I could see, hopefully you can see on screen, there's gold depositing all over the window here as it evaporates off the surface, off the boat. But there's a shadow here where gold hasn't hit the window because the watch is in the way and there's a couple of metal bars here.
Of course, in ancient times, the alchemists were searching for gold. What they wanted to do was to try and convert cheap metals like lead. I think the reason they chose lead was because lead is heavy and dense like gold. They wanted to transform these cheap metals into gold so they would become rich, or even better, so they could sell the process. There was already the start of chemical engineering, selling the process to kings and rich princes so the rich princes could make gold.
Can you see the inside of the window? Okay, so see we've got a nice gold film here on the inside of the window.
It's a shiny window.
So we definitely got some gold evaporating.
The famous physicist Isaac Newton was very keen on alchemy. And although his work on gravitation, mathematics was brilliant, his work on alchemy was rather more misguided.
Okay, so here comes the watch. So let's see, has the front of it gone gold? It has. And it's made a bit of a mess on the front of the watch. And I think it got a bit hot and it seems to have melted the window on the front of your watch. So we've got a gold film here on the outside of your watch, but you can see there's gaps in the gold. So you can see here there's a little silver band, and that's where we clipped it onto the holder to keep it in place.
Well, that was a pretty nice video. Thank you so much for watching. We'll see you next time. Stay smart. Bye.